Hey guys, Steve here. Now, two things that many of you guys know about me. Well, the first is that I have the good fortune to be related to a math god, my brother. And the second thing is that I've always wanted to be E-famous. So I've decided to kind of take advantage of the intersection of these two things. So I'm going to be putting together a video here for you today about math, because math is hard. So as you guys know, we're learning about infinite series and that sort of thing. So Ben just asked me about number 35 from the book, so I'm going to do number 35 out for you guys. So I got my little tablet here, so I should be able to draw kind of neatly. I'm going to write number 35, because I always put the number right up top, so I don't forget what number I'm doing, because I'm bad at math. Anyways, alright, so we got, our question is, we're finding the sums of convergent series, okay? So we already know that this series is going to converge. And we're just going to find the sum of it. So we don't have to do any convergence, any sort of convergence tested. Just going to be finding the sum. So we're going to have the sum, n starting at 2, all the way up to infinity, of, what do we got here? 1 over n squared minus 1. Okay, now, spoiler alert, this is a telescopic series. I didn't really know how to tell that just from looking at it. I mean, Nick was just helping me out with this, and he said, bro, it's a telescopic series, so I kind of took his word for it, okay? I think as you just do these more, you just kind of get a feel for them, and you realize that things that look like this will be telescopic series, okay? But anyways, we're just going to kind of take that, just, take my word for it, telescopic series. All right, good. So what we're going to do is, first thing is we're just going to factor out the bottom here. Difference of two squares, we got n plus 1 and n minus 1 right there, okay? So now, we are going to, since we have our two factors on the bottom, we're going to do partial fraction decomposition. So we're going to have, this is just like we did in class the other day. We're going to have a over our first factor, which is our n plus 1, and then plus b over our second factor, which will be our n minus 1, okay? So now we got to find a and b, obviously. So I'm just going to be using this part of the equation right here from there on over to there, okay? Ooh, actually, I can draw a line here for you. I'm going to be using just this, okay? Now I can actually get rid of that line because I don't want it there anymore. Oh, that was awesome. Okay. So I'm going to multiply each side by the n plus 1 and n minus 1. Okay, I'm going to multiply each side by that. So on the left, I'm going to start back down over here. I'm going to have 1 because I multiplied by the whole denominator. And that's going to be equal to a times n plus 1 times n minus 1 all over n plus 1. Okay, and then we have plus b times n plus 1 times n minus 1 all over n minus 1. So yes, obviously these are going to cancel out and these are going to cancel out, okay? But I just did that out just for the sake of, showing you guys everything. Just, taking baby steps here because that makes it easiest. Because I find, I don't know, at least for myself, when I start taking shortcuts in my mind, and then I do them wrong in my mind, and then since I didn't write anything, there's nothing to check to see what I did wrong, and it snowballs from there, and I get everything wrong. So we're going to be doing baby steps here. So as you can see, I just canceled out my factors there, so we have, I'm just going to simplify, 1 equals a times n minus 1 plus b times n plus 1. Okay, so now we're just going to select our values for n and solve for a and b, okay? So now, you see our factors here, we have n minus 1 and n plus 1. I'm going to choose an n that's going to make either a or b go to 0, okay? So I'm going to make a go to 0 first. So I want n to be 1 because 1 minus 1 is 0. 0 times anything is 0. I'm going to get rid of our a. So I'm going to use n equals 1. That's going to give me b, okay? If n is 1, it's going to be b times 2 here equals 1, okay? So 1 divided by the 2 is going to leave me b, so b will equal 1/2, okay? Now I'm going to choose a new value for n, okay? Now I want my b term to go to 0, so I'm going to choose -1 for n. So -1 plus 1 is going to be 0. b is going to go to 0, okay? So n equals -1. It's going to give me my a, okay? -1 minus 1 is 2, so I'm going to have -2a here and my 1, okay? 1 divided by -2 equals a, which is negative 1/2. Cool. So we have our a and our b. So now we can go way back up here and rewrite our equation. So our a was, okay, now as I do this, I'm actually going to flip it around so that I have, well, actually, no, I'm not going to. I'll make it, do this in different steps here. So our a was negative 1/2 over n plus 1, right? And we have our b, which was just 1/2 over n minus 1. Okay, cool, great. Now all I'm going to do is I'm just going to switch the order of these things just so I can put a minus sign in there and get rid of my negative sign right here. So I'm just going to have 1/2 over n, oops, that's going to be a minus, n minus 1, okay, minus 1/2 over n plus 1, okay. Now, I didn't bother to rewrite this thing, the summing, okay, but that should be in front of each thing here because this is still a sum. So now, as we talked about, like, you can bring the, well, as we talked about in class, I didn't talk about it, you can bring the constant, okay, we can factor that out. So this is going to be our constant, our 1/2 here and here, okay, so we can bring that out front of the summing sign here. So what that's going to be is just going to bring, I'm going to factor out the 1/2 there, so we have a 1/2 of the sum of n starting at 2 up to infinity of 1 over n minus 1 minus 1 over n plus 1, okay, because I just took my 1/2s, divided those out, and I put it out front, okay. So cool. Now we've got that done. So now we have to actually sum this thing up, okay? So the way to do that with telescopic series is just start listing out your sums, okay? Like starting with like the sum of the first term, then the sum of the first two terms, okay? So how we were doing that was we're starting off with our sum 1, okay? This is going to be the sum of the first 1 terms of this series, okay? So the first sum, we have n is going to start at 2, okay? So the first sum is going to be 1 over 2 minus 1, which is 1, minus 1 over n is 2 again, 2 plus 1 is 3, okay? So our first term is just taking all of this stuff and plugging n in, okay? Now, sum of 2 is going to be the first 2 terms, okay? Now, S1, that's our first 1 term, okay? So we're just going to bring that down. So we have 1 minus 1/3, okay? Then we're adding to that our second term, okay? And our second term is going to be everything here with n plus 1 plugged in for n, okay? So we just did n as 2, now we're going to do n as 3 because that's, you know, n plus 1, okay? So our first half here is going to be 1 over 3 minus 1, which is 1 over 2, so we're going to put a 1/2, and then minus 1 over 3 plus 1, which is 1/4. Okay, so that's our second term. Now, you know how telescoping series work is they, you'll start to see these terms cancel out like we did in class. Usually, I mean, I haven't done a lot of these either, but for me, if I go to the 4th term, if I go to the 4th sum, then usually I'll be able to see the pattern. Okay, so I'm gonna do 4 sums here. So let's do the third sum here, the sum of the first 3 terms. So I'm gonna bring down everything I have because that's my first 2 terms.